All right, hi guys. I want to talk about our team project. Recently, we know that the convolution neural network is a commonly used structure in daily in researchers. However, most of the time, people pay more attention to the structure of the whole network. Like in this paper, they do the research on different structure like multiple layer perceptron or INLP to test the different accuracy from that special structure. However, we wanted to use a different perspective. We wanted to know how the kernel size will affect the performance. Our idea came from that paper from Sichka. And in this paper, they discuss how the kernel size will affect their network. However, they do the experiment in multiple epochs, and they got the final accuracy to do the comparison. However, in our network, we just do one epoch loop and see how the kernel will affect. And our dataset is a traffic sign dataset with 32 times 32 pixels. All right, let's see how can we do that. First, we try the kernel with square shape, like three. Like in this point is 3 times 3, and in this point is 15 times 15. We see that when the kernel size is 10% of the image height is the perfect performance, and then gets to a value and go up again. You will see the similar performance later. Like here, we extend the idea from this paper. We not only just use the square kernel, but we try some rectangular kernel. In this plot, we try the different rows of a kernel, but to adjust the fixed row, but adjust the number of columns. We see that when the kernel is still have 3 rows, it will get the best average performance. For the larger things, you will get more variance. The same issue happens when we fix the column of the kernel and adjust the rows of the kernel. You see that there is a value in 19 points. Then you see in the deep network, here we define the deep network with 3 convolution layers. In previous experiments, here we just use 1 convolution layer. You see that there's still a value in 18 points, because we think that, as you know, the concept of the convolution, the operation will has to pad some points. If we use that here, like 18 times, like 20 times 18, you have to use a even number of kernel size, and then more zeros are added here. So this, in the result, this number cannot represent this region. Thus, here why the value comes out. But after that, when we get a extremely large kernel size, it will cover most of the information because it will fall on the center of the image. And finally, we do the similar experiment with the convolution network applied with the Gabor filter. You see that is what happened in the in fixed Gabor filter. It means that we use the same parameter for each kernel. And here, an interesting result is that when we dynamically change the Gabor size with the changing of kernel size, you can see that we get a perfect graph. And you see that when we choose 3, the performance is the best. And if you want to know more details result, please refer to our report. Thank you.